Alright guys, here's the quiz reviews to take from 2.5 to 2.7. Thought this was a pretty motivating song, so just sounded like fun, but I guess let's get started on this. Alright, here we go. So we're graphing inequalities. So for number one, we've got two basic styles to work with here. The first one is the most standard kind. It is where it's in slope-intercept form. So we have a positive 2 here on the plus b part. In other words, that's the y-intercept. So I'm going to put a point right at positive 2 on the y-axis. And then the slope tells me to go down 1 and right 3. So I'm going to go down 1 and then right 3 places. Put another point. Because it's a regular inequality, this will actually be a dashed line running through here. And it's less than, so I would shade downward from the line. So if I put my pencil here and go downward, this is the area I should shade. So that shading should be down here in this area. Number 2 is the other kind of problem you're going to see. It's where the x and y are together. It's set up to do the intercept method. So you treat this like two small problems in one. Rather than moving everything around to get y by itself, if you just do 10x equals 50, and we solve that for x in one step, we get negative 5. That's one thing we will look at. And then I also do 25y equals 50, and in one step I get y equals 2. Okay, those are intercepts, so that tells me that all I really need to do is plot this on the x-axis and this on the y-axis. So on the y-axis, there's y equals 2 right there. And then I actually have to keep this a little bit. I'm going to bring this. Never mind. Go back. I'm going to fix this for just a second. It's a little longer. So I need to put x is negative 5 on the x-axis, but I guess you have to count over. There's 2, 3, 4. Here's where x is negative 5 was. That's why I had to make that longer. So this goes on the y-axis, this goes on the x-axis. The idea is that the method is different. This is slopes, this is intercepts, finding an x-intercept and a y-intercept. This is when you already have a slope that's easy to see. You can use y-intercept and then use rise over run. So it just depends on what the problem is like. If x and y are together, most of the time, you're going to do this using the intercept method that I just showed you. Solve it for x, solve it for y. Alright, it was a greater than or equal to, so I've got a solid line to draw here. And because it's greater than, I would put my pencil here and go upward. The shaded area is up here. So this one, I basically have the same setup as number 1, but this divide by 5 can't be here. So to fix it, I'm going to multiply everything by 5. When I do that, 5 times this will cancel that 5 and give me y. 5 times this will be negative 5x. 5 times this will be positive 5. So now I have to graph this just like I would have graphed number 1. Remember, this is a slope, so I want it as a fraction. I'm going to put a point at positive 5, 1, 2, 3, 4, 5 on the y-axis. And then I'm going to go down 5 and right 1. I need a solid line because there's a line here. So I need a solid line in here. That's kind of a crooked line, but I think you get the idea. And then less than means put your pencil on the line and go down this way. So this area is shaded. Next one. This time we're faced with a problem very similar to the last one where we have y almost by itself because there's no numbers here. But this needs to be, instead of here, it needs to be over here. You can do this using the intercept method, but you're going to get fractions that will make it a real pain. So I would say that it's better to take this and get it over here somehow. It's already minus 3 over 5x. I'm just going to add 3 over 5x here and over here. So that these would cancel, and I'm left with a y greater than or equal to 3 over 5x, and that positive 2. Now it's actually really easy to graph. I'm going to put a point at 2. Then from there I'm going to go up 3, right 5. 1, 2, 3, 4, 5. I need a solid line because of the equal to symbol. And it's greater than, so I'm going to say up the line. Okay, number 5 might be the toughest one on the paper. I think it can tell you need to distribute first. 3 times 3x is 9x. 3 times negative y is negative 3y, all greater than negative 12. Okay, I would look at this and say you can move stuff around if you want. You can also use the reciprocal. Either way, you'll get the same answer. So I'm going to go, or excuse me, you can also use an intercept method. Either way, you'll get the same answer. I'm going to do the intercept method. I'm going to say 9x equals negative 12. And when I solve that, I'm going to get x equals negative 1.33. And then I'm going to do negative 3y equals negative 12. And when I solve that, I get y equals 4. So on the y-axis, I need a point where y is 4. And on the x-axis, I need a point where negative 1.33 is. Well, here's negative 1.5. Negative 1.33 must be right in here. Regular inequality, so I need a dashed line. And it's greater than, so I'm going to shade open. Finally, for this last one, it's something you're just going to have to remember, I guess. Anytime you have a y without an x, that's a horizontal line. Take that back. That is, yes, it is a horizontal line. Sorry. Y without an x is a horizontal line. So this means draw a horizontal line where y is 4, right here. It'll be solid. And then, because it's less than, we'll shade down here. Like that. Okay, these ones ask you to write an inequality from what you're given. So most of the time, if you see a diagonal line for sure, you're going to start with a y equals or y is less than or greater to greater than mx plus b kind of equation. So in this case, all I really know is that it's going to have a y and an x in it. I don't even know what the symbol in the middle is. So it's going to take a little bit of work, but you can get this without too much effort. All right, so let's start with what the symbol is. Well, I see a solid line, and I see it going up from the line. I'm guessing that means it's greater than or equal to. Greater than because it's up from the line, and equal to because it's a solid line. All right, now I need a slope and I need an intercept. Well, the intercept's real easy. It's right there. Y is negative 1. That's the intercept. And what does it take to get from there down to this other point? Well, I've got to go down 3 and right 4. Down 3, right 4. That's your inequality. This one isn't too much different. Let's look at the shading. It's down, so it'll be less than. And it's dashed, so there's no equal to symbol. It's just less than. So we're going to need a slope and we need an intercept. Intercept is positive 2. Okay, a lot of people have questions about how do you get this slope. People trying to count here and backwards. Well, what makes the difference if you count here and back or you count here and up? Either way. So I would say since we always count to the right, let's go up 1, 2, 3, 4, and right 1, 2, 3, 4. That's what I would do. So it's actually 4 over 4, or in other words, 1x plus 2. So some people don't even write the 1. It would just be y is less than x. And finally, we have a vertical line. Unlike number 6 here, where we had a y by itself and no x is a horizontal. Number 9 shows us a vertical line, which tells us it's x by itself with no y. I see a dashed line, and I see the shading to the left, which to me says, here is 4, right? 1, 2, 3, 4. Well, the shading is to the left, like where the stuff that's less than 4 is. So this is actually less, and then it's at 4, so we write less than 4. All right, we're on to the last problem, the scatter plot problem. Certainly the one that takes the most time. So when we get to this one, you're looking at like a 15-point problem. All right, so this reading through the directions, it says make a scatter plot. All right, that means that you're going to have to scale your graph, and you need to label your graph correctly. So if I look at this, it says horsepower here, mileage here. That's horsepower on the x, mileage on the y. So I'm going to write horsepower here and mileage here. That's miles per gallon. Okay, so it looks like horsepower goes as high as 255 and mileage goes as high as 35. I need to make that fit on this graph. So I think I'm going to do maybe on the bottom, I'm going to say by 20s. So this is 20, 40, 60, 80. Here's 100. 20, 40, 60, 80. Here's 200. 20, 40, 60, 80. Here's 300. Just for fun, 20, 40, 60, 80. Here's 400. Now, if you scale it differently, doesn't mean that it's going to be wrong. It just means that it'll look a little bit different, maybe more spread out. And it also means that your equation might be slightly different than mine, but the whole idea is to follow the process and come up with a pretty good approximation. So mileage, I got to get up to 35. I'm going to go by 2 that time. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Okay, now it's just about plotting some points. So I'm not going to make you sit here and watch me plot all these points. I'm going to do it real quick and then I'll come back. Okay, so now that I have my points plotted, I really don't need this big chart anymore, so I'm going to take it out of the way just to give us more room. That. All right, I need to draw in a best fit line. That is step number 2, draw in a best fit line. So sometimes it takes a few tries to get this, but you can see that I have a lot of data right in the same general area right in here. I have a couple a little high, a couple a little low, but really here's like a straight line more or less right here. So I'm going to draw it just kind of like that. I think I'm going to make this line basically go right through here. Notice that I'm bringing it back to touch the y-axis. So there goes my best fit line. Now the reason I'm saying this is the best fit line, it's not bad. As you can see, most of them are right here, very close to it. And the some that are far away here, this distance away here is about the same distance as this is away over here. So the points on this side are this far away, and the points on this side are about the same distance away on the opposite side. And then I have a lot of them right in the middle. That's what I'm looking for in a best fit line. All right, so step 3 says write an equation that represents the data. All right, it's an equation, so we don't have to worry so much about the inequality symbol, obviously. We just need an M and a B. All right, the reason you have it touch the y-axis up here is it tells you where you're going to graph your, or where you're going to start your y-intercept at. Mine is just above 40, like somewhere up in here. So I'm going to use that spot. I'm actually going to highlight a different color. That spot that I'm saying right there, it looks to me like, I don't know, a block is 2, so I'm saying that's like almost 41. I'm going to call it 40.5. Positive 40.5. Now, I need to find another point that's easy to spot on my line here that is not one of my original dots. So it looks like I have a pretty good one right here. I'm going to use that one. I'm going to count down from there, down to here, and over. That's how I'm going to figure out my slope. So it looks to me like, I said I have a 0.5 here, but it's basically 2, 4, 6. So I'm down 6.5. I mean, negative 6.5 over, and I'm going to go over 3 blocks. Remember that going over 3 blocks that represents 20. So that's actually 20, 40, 60. Negative 6.5 over 60. Well, that's kind of an ugly fraction. So I'm just going to go ahead and estimate it and make it a decimal. So I'm going to take negative 6.5 and just divide it by 60. I get negative 0.108, I'll round it to negative 0.11. So my final equation is negative 0.11x plus 40.5. So that takes care of step 3. So this is something you'd want to highlight as your final equation. Number 4 says, determine how many miles per gallon a car with 400 horsepower gets, and then it says use your equation. All right, if you notice, we plotted horsepower on the x-axis. That means that x is where you put horsepower at. So for this problem, I'm going to do y equals negative 0.11 times 400 plus 40.5. So again, this is probably a calculator problem. So I'm going to take 400 times 0.11 times negative 0.11. Then I'm going to add 40.5 to it. My answer is actually negative 3.5. Well, that seems kind of weird, but that's what happens in our equation, so I'm going to go with that. So, number 5 says, discuss whether you think this is a positive or negative, as well as a weak or strong correlation. So for number 5, I would say, well, it's clearly negative, it's downhill. But you do have some points that waver off of it quite a bit. I'm going to call this a weak negative. So this was my answer to number 3, this was number 4. Number 5, I would say it's a weak negative. Because not all of the points are very, very close to the line that we drew. We have some that are off a little bit. I'm going to go with a weak negative there. Number 6 says, describe what your data indicates, and then is your equation good for any amount of horsepower? Explain your reasoning. Okay, in general, what does the data say? Well, to me it says, as your horsepower goes up, your gas mileage goes down. Well, that makes sense. But the problem with that says, is it good for any horsepower? Well, I would say no, because if you look at it, when we entered 400 horsepower, we got a gas mileage of negative 3.5. How could you have a negative 3.5 miles per gallon? Doesn't make any sense. So the answer to number 6 is more or less an explanation. You would say yes, it does indicate that as horsepower goes up, gas mileage goes down. But it doesn't really work for all of them. In fact, once you get out of the range of where these dots are at, it really doesn't work anymore, because if you get up to, say, like right here, it says once you get to about 370 horsepower, right down there on the end, like this, right here, once you get to about 370 horsepower, you cease getting miles per gallon. Your miles per gallon will be zero. That doesn't make any sense. So I would say that this is a relationship that says as horsepower goes up, your gas mileage goes down. But really, it isn't perfect. It has some limitations. And basically, I wouldn't use this equation unless my horsepower fell in this kind of area. You know, if I had a horsepower from about 100 to 250, I think it's a pretty reasonable equation to use. But other than that, I would say I'd probably try to find something else. All right, that's your quiz. That's your quiz review, I should say. Good luck tomorrow.